and please help this channel get at least 20,000 subscribers already. So it means a lot for me and for us, and it helps me really do some great content. Thank you. Hello and welcome back. It's Amin, and we are here for the fourth tutorial, and today we will be discussing functions. Yes, I changed the theme of my Jupyter notebook, and you can do it following these two commands. You install Jupyter themes and you use this with pip, or you can do it with Conda, whatever, and you can do it with this command Jupyter theme -t monochi blah blah blah. If you do it through Jupyter notebook without command line, you can do it this way actually, and you can install from the Jupyter notebook. So we can go forward with the code. Here we will start by defining the functions. Let's say we will define a functions which is Fibonacci, for example, Fibonacci series. I will define it like this. We start at a equals 0, b equals 0, and while a less than n, smaller than n, we print a and we print a space, and for a it will be b, it will be the next value of the next one, and b will be a plus b. It's a very recurrent function to develop. So this is Fibonacci of 2000, and you can see how very fast it develops. So this is what is a function. It's a function. It's a function object, fib, and we can do also like name it to make it have another name, like f equals fib, and f of 100. If Fibonacci of 100 is this. It prints the list of the Fibonacci series. 100, not the first 100 ones. Well, we can change it to print like the first 100 ones for an example, like here we have fib till n, and while let's say here we can add like something like count, but we will have 2000 of this, but we can do it till 100. For example, we can add count and say, okay, we will start counting at 0, and while count, let's say less than n, let's say we'll say, okay, Fibonacci of the first whatever numbers, whatever Fibonacci, the first 100. Let's say we want to make the first 100 Fibonacci element, count blah blah blah, and here we say count plus equal 1. This is an operator. We will also I didn't talk about it, but we will also have a look at it. It's like equal count plus 1. It's like we increment the count. So instead we'll do just count like this. And normally with this we'll have the whole the first the first n, like do like Fibonacci of 100. We will have the first 100 Fibonacci elements. If you see, that's why I didn't do 2000, because it will take quite a lot of space and a lot of yeah, let's say just a lot of space. For here it's this one, and let's say Fibonacci of 0. Here it's nothing, because we don't have actually the value of Fibonacci of 0. It's also like it's nothing, since it's not for no elements even for this function. So if we say what is the Fibonacci, the fib 0, or print fib 0, it's none, it's nothing. Next forward, we'll have another function of Fibonacci, and here we will make a list. Before we have done it in some kind of string with some space, like we end at space. Here it will be like results, and we will append each time the result A. And here we can see that it will return a list. We can do the same, like we can do the same exercise here a bit to practice. I can leave it to you, and you can comment it in the comments if you find how to do it for the first 100 elements. It's going to be a nice exercise. Next forward would be the default argument values. Let's say here we want we have arguments. First we have, in the first function we had just one argument, and now we have we can have multiple arguments. Let's say we have some we have a prompt. It's what we will input when we will answer. For example, for this function, we'll have a number of retries. This retries here is it's in here, and it's when you have used all your retries, you will have an error, and each time actually you use this stuff, it will say, okay, you have it's too much retries already, and here you have reminder, please try again, and here reminder when you don't actually. It's like we want you to have an answer in this one, in this list, or in this list, and we'll okay. And let's do it. So do you want to quit? I will do my for retries, so I will just say some stuff that is not in these lists. A. So here I have the error here because I have done a lot of retries. Please try again. We can say, okay, do you really want to quit? Yes, that's enough. But still, this yes is not the correct yes, which is not in this thing. So we just type the normal yes. So it's true, and when you return true, you're out of the. Actually, when you return a value, you're out of the function. So each time you return, you're out of the function. Let's say here no, and it will be also false, but you return a value, so you have a value. And here we return, this is what we call a Boolean. We can go, we'll see into types also later on a bit, what a Boolean type is. And Boolean is like true or false, 0, 1. They're also quite useful in programming. Also, this value error is an error. We'll also dig into it more in details later on. Here we can change the number of retries. Here the second argument is retries. We can change it. Let's say here we have just 2 retries. I do it 2 times, and the third times they will say, okay, that's too much. You have done your retries. The other one will have 2 retries, but the message, like the reminder here, they say please try again. Yeah, the reminder will change. It will be like something here because we print this kind of reminder here from this function. So if you see, we take that. We always kind of use the same arguments in the function. So we will use here these arguments in the function. So we use these arguments. We say, hey, okay, come on, only yes or no, and that's fine. And here you say A and okay, I quit, but I do it this way. Yes, it shouldn't be, because there is also a difference between uppercase and lowercase in programming, in case if you don't yet know it. Another thing is scopes and functions. For example, here we define a function, and with the argument it's 1. It's I, and I we define it some way, it's 5, and here we print the arg. Even if we change I equal to 6, but f prints actually prints this one at this place. Actually, it points. Let's say it prints it here when it is since this I is before this one. If this I was, let's say, before the definition of this function, it will be 6. Or if both of those I's were after this function, it will be an error. Or it won't be an error, since here in Jupyter, like, I is saved. But let's say another G, it will be an error because it doesn't know what is J. So this is for this. Another thing that we have to be very careful is here. For example, this one is kind of immutable. But what about if we have a list and it's a list that is kind of mutable? Here we say, okay, I'll equal this kind of empty list, and each time we call f, we with an argument a, we append actually this list with a, and we return the list. If we do it 3 times, actually the list that is inside the function gets appended 3 times with the value. So here it's not a list that is empty anymore. We sometimes want to have just an empty list and append one element, or maybe we want this kind of behavior, but we can prevent this kind of behavior of happening by doing it this way. Instead of doing it with like a list like this, we can initialize it as being none, and we say, okay, because if we call it here without calling L, it will be none. So we say, okay, if list is none, list here we do list equal to this, and then we append. So if we retry these ones, okay. No, it's this one. Sorry. So if we because I was doing it on the other. So if we do this function right here, we will reinitialize each time L, which is important for us, and we will have shown a new the new list, and we can control it. Here we can, for example, if we wanted the list of before, like 2, 3, we'll have 2, 3 here. We will append 1, 2, 3 somehow. No, wait. No. F 1, 2, 3. More like this. So we'll have this. If we can control this behavior, this is the main point of knowing this. So it's to keep in mind.